Alright, so in this video lecture we're going to be talking about balancing chemical equations and the law of conservation of mass. So your essential question is, can matter be created or destroyed? And the answer to that is no. The number of atoms you put into a chemical reaction are going to be the same number and the same types of atoms that you get out of a chemical reaction. They just rearrange themselves into different chemicals. The only difference is in nuclear reactions, which we are not studying yet. But in nuclear reactions, a small amount of matter can actually appear to be lost because it gets converted to energy. So you're going to be filling this out on the front of your 3.6 handout. So you're filling in your notes. Feel free to pause or rewind the video as you need. So basically, the law of conservation of mass just tells us that matter and therefore mass cannot be created or destroyed during a chemical reaction. So we have to have the same number of atoms going into the reaction on the reactant side as we get in the product side. We show that mass is always conserved in chemical reactions by balancing out the chemical equations. So we need to show that there's the same number of atoms on the left side of the arrow as the right side. You can't add or change the subscripts. Those are those little numbers written down at the bottom of the chemical symbols. You can only add coefficients. So this is just an example to show you the synthesis of water. We've got one diatomic hydrogen molecule, one diatomic oxygen molecule, and they are synthesizing H2O. If we look at the number of atoms, you'll see that they're unbalanced. We have 2 hydrogens on the left and 2 on the right, so those are fine. But you have 2 oxygens on the left and only 1 on the right. So what sometimes I will see students try to do is just put a little subscript down there. Yeah, the oxygens are balanced, but you just changed the chemical. It's not water anymore, it's hydrogen peroxide, and you can't just go around changing the actual chemical. So instead of changing the subscripts, what you can do is add coefficients. So just like in math class, a coefficient is a number that goes in front of a variable. We can multiply our chemical formulas by the smallest whole number possible to make the atoms the same on the left as the right. So to balance out our oxygens, if we have 2 on the left and 1 on the right, we can make that 2 on the right by multiplying the whole chemical formula by 2. So now we're just showing that we have created 2 H2O molecules. So our oxygens are all balanced, but our hydrogens aren't balanced now. So now we need to add a coefficient on the hydrogen side to make it so we also have 2 more hydrogens, so 4 total. So if we put a 2 on front, we are multiplying that H2 by 2, and now we have 2 more hydrogens for a total of 4. So this is now balanced. I'm going to show you one more example. Although it's helpful to draw out the atoms, it's not realistic to draw that out for every single equation. So what you can do that's a little easier is take an inventory of the atoms that you have. So if we look on this side, we can see we've got 1 magnesium on the left of the arrow and 2 oxygens. If you look on the right side, we have 1 magnesium and just 1 oxygen. So our magnesiums are balanced, but our oxygens aren't. We can't turn the 2 over here, we can't turn that into 1 because you can't multiply by a whole number to bring that to 1. However, you can multiply the other side by 2. And so now we've got 2 oxygens, but that also changed our magnesium. So now we've got 2 magnesiums on that side. So if we go back to the left side of the equation to balance out our magnesiums, we can multiply this by 2, and then we are all set. So that's it. Go ahead and finish the practice problems on your 3.6 handout, and you are all caught up.